Okay, these are problems 31 to 33 on the lesson 7 in chapter 11, the laws of sines and cosines. And in this figure, they have labeled on the earth, they've labeled 2 points on the surface of the earth, and then they've drawn the moon out there, and they've created a triangle out of this. And the points A and B are supposed to be observatories on earth, and then they're looking at a mountain peak on the moon. And they give us some information, and they want us to find some missing things here. So one of the things they want us to find is angle M, the angle over there by the moon. I'll mark it, let me mark it with red. They're wanting this angle right here. Well, now, we don't need any trick for that, do we? Because we know all the angles in a triangle add up to 180 degrees, so we have the other two angles, angle A and angle B, and if you notice, they're pretty large angles, close to 90 degrees. So angle M is going to be teeny tiny, we can already see. So if I take 180 and I subtract, I'm going to go ahead and add these two together over here. 4 plus 2 is 6. 9 plus 9 is 18. Pound your 8, carry your 1. That'd be 178.6. Okay, so let's see, let's kind of reason this out. 180 minus 178 would be 2, but you're subtracting 0.6 more, so this would be 1.4 degrees. Okay, so what is angle M? Angle M is 1.4 degrees. Okay, all right, let's look at 32. 32 says, find AM to the nearest 1,000 miles. Okay, so we're going to round to the nearest 1,000 miles. We now know this is, angle M is 1.4 degrees, and they're asking us to find, let's see, AM over here. I'm going to call this side little b because it's across from the B. Now, here's what we could do. We could use the law of sines to find that side. We could also, possibly look at using the, well, let's see, we can't use the law of cosines yet because we don't have enough sides. We have to have at least 2 sides in an angle to use the law of cosines. So we could use the law of sines here. Now, here's what I'm going to do. I've got the angle M now. I just found it. So let's see, the side across from M I'm going to call little m, okay? So if I take the sine of angle M and put it over its opposite side M, that would be the same thing. I could set it equal to the sine of B. I know B, right? And I'm trying to find AM. The side across from B is AM, so little b that I'm trying to find is this AM they want me to find. I'm just labeling it so I can show you the relationships between, we have 2 angles and we have the sides opposite them, except for opposite B. That's the thing I'm trying to find, so I have to work it into my equation somewhere. Okay, so let's fill in the information. We found out that angle M in the number 31 was 1.4 degrees, so it's the sine of 1.4 degrees over the side across from it, and it's hard to read that labeling, but if you're looking in the book, that was 5,280 miles. Okay. All right. Now I know what angle B is. That was given to me in the problem. That's 89.2 degrees, and the side across from it I have called little b. So now what I need to do is cross multiply to solve. I could say B times sine 1.4 degrees is equal to 5,280 times the sine of 89.2 degrees. So I'm going to have to go put, in a minute I'll go to my calculator. You know what I'm going to go ahead and do is solve for B. I'm going to divide both sides by sine 1.4 degrees so that I can type all this into the calculator. When I type this into the calculator, I'm going to want to put the whole top in parentheses and then divide by the sine of 1.4 degrees. I forgot to copy that down. And that will give me my B. So I can actually put all this in the calculator in one, just one long string. So I'm going to go get my calculator and do that. Okay, make sure your calculator is in degrees, especially if you have a TI 83, 84 you're working with. It works in radians is the default. If you've got some little scientific calculator, you're going to have to figure that out for yourself. You're supposed to have a TI 84, and that was part of what you needed for Algebra 1 and still part of what you need every year after that. So hopefully you have that. When I plug this in, here's what I'm getting. B is 216,087.3784. They told us to round to the nearest thousandth, okay? So we're rounding to this place right here. There's ones, tens, hundreds, thousands, okay? So the zero that comes after the 6 will not round the 6 up. So this is about 216,000 miles is that side B over there. And that's the distance from one of those observatories to the moon if you think about the problem. Okay, so I've just redrawn the triangle since I had to go to a new slide, and just now they want us to find the side BM. That's little a. Okay, so for 33, we're supposed to find BM. In my diagram, what I always do is I always label the side across from an angle, like, and this is what you typically do here. Since this is angle A, the side across from it would be little a. I can use the law of sines here also. Now, I could, theoretically, I could use the law of cosines, but the math on it is so hard, we try to avoid it unless we have to use it. So over here for BM, that's what I called A. So I know I need it in my little equation. I'm going to use a law of sines. I'm going to say the sine of angle A over little a, that's what I'm trying to find, BM. And now I just need to pick another side where I have an angle and the side length. Well, if you look at, I could use either angles M or B here because I have enough information. I like angle M because it's a small little 1.4 degrees. And if you look at the number across from it, it's 5,280, which is a nice whole number. And so I'm going to choose to work with that just because, sometimes you just, you make a choice. I'm just making a choice here. Now, if you were to have chosen to work with angle B, I would have typed all that in as my length for B. We rounded it for the answer, but probably to get a really accurate answer, if you're going to choose to make your second fraction sine B over B, I would use that whole length there. The book may not. I don't know what the book does. I don't really care what the book does. I'm not going to be bound by the answer key here, but if you were trying to be accurate, you need to use as accurate information as you can get. I'm just avoiding that problem here by choosing angle M. Okay. So what is angle A? Let me plug in my information now. Angle A, I wanted the sine of angle A. It was 89.4 degrees, and little a is what we're trying to find. That's the side BM they asked us to find. I just labeled it a different letter so that I could see that it's across from angle A. It's the sine of angle M. Well, angle M is 1.4 degrees. We had found that back in problem 31. And the side across from it was given to us in the problem. It was 5,280. All right, so if I'm going to solve this, again, I have the thing that's great about the law of sines is we can cross multiply to solve. So I'm going to write down a sine of 1.4 degrees. I always put the trig function part last when I'm multiplying. I'm going to put the a out front just because that way it's a little easier for your brain to kind of process it. And then I'm going to set that equal to cross multiplying the other direction. And again, I'm going to put the 5,280 out front, sine of 89.4, just so that I don't accidentally type in something into the sign in the calculator when I'm putting it in. Now, if I'm trying to solve for a, I want to divide both sides by sine 1.4 degrees. That's a degree mark there. So I'm going to divide by sine 1.4 degrees on both sides. That cancels out and just leaves me a equal. Then I can type all this in the calculator. Now, here is, I've got two terms in my numerator, so I need to put parentheses around it. If I'm going to type all this in the calculator at one time, let me put parentheses around it and type in parentheses 5,280, and then I can just hit sine 89.4 in the TI. It knows that I'm multiplying. And then I can close my parentheses and hit divide by sine 1.4. You can close your parentheses. You don't have to here. You can go ahead and hit enter. And what I'm getting is that it's about 216,096.5945. Okay. Now, they wanted us to round in nearest thousandths, and the nearest thousandths place, again, is going to be looking right here. If you look down at the next number, it's a 0. That would not round it up. So this would also be about 216,000 miles if we round to the nearest thousandth. And what you might notice about your answer to 32 and 33 is that they're approximately the same. There was a slight difference, but they're approximately the same, and that kind of makes sense because if you look at angle A and B, this is not an isosceles triangle, but it is almost an isosceles triangle because look how close A and B are together. So it would make sense that the sides across from them are going to be pretty close together too.